So in previous lectures we have seen structural member command in Weldments. This is lecture number 2 for Weldments. We are continuing the earlier lecture. In first lecture we have seen till structural member. So now we'll move further and see the other remaining commands. For that I'll again change the cross sections here. First we have taken angle iron. Now I'm going to go for square tubing or rectangular tubing here. So I'll say edit feature. Select the rectangular tubing option and go for the size. I'll say it as 60 by 40 by 3.2. So this is length, width and thickness. I'll select it and then say OK. We will just check the corner treatments. They are coming in proper way. Both the horizontal structures are overlapping the vertical ones. Now we'll continue with the second group here. Then we will go for the table legs. So for the second group, I'm going to take the same size for this profile also. I'm going to select the group here, say edit feature. And in group 1, group 2, next I'll say group 3 here. Sizes I'll continue with the same sizes. Select these bars. And say OK again. Now in this group we need to change the alignments. So for that I am going to select it and say it edit feature again. And I want these vertical tubings to be coming inside the horizontal tubings. For that I am going to change the corners for this upper side at left side. Say invert 1. Here we will select the type which is opposite to invert 2. As invert 2 is pre-selected, I am going to go for invert 1. So this is opposite of invert 2 and then say it OK. Now this is updated. From both sides this vertical tubing is coming inside. Now I'll go for the right side tubing. Here you can see this side is overlapping of this pipe. So I'll select this side and go for invert 2 here. Say it OK. Now all the sides have been updated here. Say it OK again. And now we can see here square tubing at all sides has been updated here. Now I'll go for these pipes or legs. For that we are going to select structural members. As I am going to go for the new cross-sectional shape, that will be pipe. So I need to select structural member again. We can't continue in this group only as the shape and size has been changed here. So I'll select structural member again. Go for the pipe. I'll select the maximum size of the pipe here and add them as a supports here. So we can see here pipes are been added as a support. Again said OK. Now I need to orient this rectangular tubing. As it is vertically oriented, I want to orient it again in horizontal direction. So I want this face to be oriented at horizontal direction. So I'll go for edit feature in rectangular tubing. And for group 3, as it was taken in group 3 here, so I'm going to go for angle and update the angle by 90 degrees here. Say it OK again. If I would have kept that vertical orientation, this joint would have been weakened here. That's why to make a strong joint, we need to select such a face that it would accumulate the cross section of the pipe. That's why we have oriented to 90 degrees this rectangular tubing. We need one more support here. If you want to update, you can update the 3D sketch here. I'll add one more line here. We'll also update the height. I'll say 200 mm. Exit. There will be no change in structures there. And now I want to add one more group here of the same cross section. Now I want to add one more structure here. It should be in rectangular cross section only, but the size will be a little bit smaller or customized here. So for that I'm going to go for structural member. We can't add another group here. It is because we are going to change the size. So if I update the size in this similar section or similar type, then all these sections will be updated by the same size. But I don't want to change the sizes of this rectangular tubings here. I just want to update the size of the middle one, lower middle one. So for that I need to select another structural member and then go for the size. I'll select rectangular tubing. I'll select the size as 50 by 30 by 2.6 and update it here. I want the orientation to be horizontal, so I'll make it 90 degrees angle. It is coming perfect now. Say it OK. You can see another structural member has been updated here. Now we will hide these sketches. Now if you see these rectangular tubings or pipes, these pipes are been intersected in these rectangular tubings here also and in mid portions also. You can see here on all the four sides these pipes are intersected to the rectangular tubings, as well as you can see this another added rectangular tubing. It is also intersecting the body here. You can see the blue shade being shown here as it is intersected inside the body. And one more thing to notice, that there is no edge formation in this corner. It is because when a part is flushed or intersected in the other part in SolidWorks, the edge formation doesn't appear there, indicating that these parts are flush to each other or intersected to each other. If I locate this profile of the rectangular tubing at upper sides, this pipe will automatically come below the rectangular tubing. We will go for that option here. First we will see it by updating the position or locating the profile, and then we will go for trim commands. So I'll select the rectangular tubing, edit feature, and now you can say locate profile. I'll locate this profile to upper sides, as this complete structure will come at upper sides and the pipe will remain at the lower side. So for that I'm going to select this point, and now you can see whole structure has been updated to upper sides here. I'll also update the group 2 here. For that also I'm going to go for the lower point here. So the structure will move upwards. Say locate profile and then click the required point. This structure is also updated here. Say OK. And now you can see these pipes are not intersecting the model here, as we have moved complete structure only upwards. Sketch and pipe sizes are same, but this structure has been moved upwards. But there is one more problem if we do this. If you don't want to change or update the height, then it is better to keep this pipe intersected as it is and then go for trim commands instead of locating the rectangular tubing upwards. So I'll Ctrl Z or undo this. You can see I've undone that command locate profile, and again it is intersecting the part here. So instead of locating, I'll go for trim command here. I'll hide the sketch first, and here there is trim and extend command. Select the command. I'll select the first option only here and trim. It is asking us for the bodies to be trimmed, so I'll select the bodies to be trimmed here. That will be the pipes, all the 4 pipes, and then we'll go for the trimming boundaries. Here we need to show the boundaries in 2 forms. We can show it either by faces as a boundary or bodies as a boundary. So I'll select the faces option first, just to show you how the face option works. Then I'll select this faces here. I'll select this bottom face as a boundary here, and for the other side also the same kind of bottom face. And now you can see on each pipe there are 2 stickers been highlighted. On the first pipe you can see here, first one, the upper side, it is dimmed in color and showing that this portion is to be discarded or to be deleted here. And the other one, other sticker on the same pipe, first and second, the other sticker is showing as to keep the parts. So I'll keep this part here. Similar is for the other pipes also. On this pipe also you can see internal pipe, discard and keep. Upper one is discard and lower one is keep. Third side also, upper one is discard and lower one is keep. At the fourth side also discard and keep. Say it OK. And now this upper pipes are been trimmed here. We have used boundaries as faces only. In similar option we would have done trimming for these pipes also. So I'll edit the feature here. And in trimming boundaries I'll select these faces also. The first one and the lower one. Again the first one, upper and lower one. And now I want to discard this intersecting portion here. So on this pipe I'll say click on this keep command and it will discard the pipe here. Again for here also, and then for this internal portion also, I'll discard. I just need to click on this option and it will be converted from keep to discard. For this internal portion also I'll say discard. You can see this point here. And lastly for this portion also discard. Say it OK. And now you can see these pipes, they are been discarded here. Now the only portion which is not been trimmed here is the internal one. You can see the projection of this mid support is coming inside the tubings here. The horizontal tubing is intersecting the vertical tubing. So I need to discard this one also. So now we will see trim and extend by using the body as a boundary. Select the trim command. Select the bodies to be trimmed. I'll select this tubing here. And in trimming boundary, there are two options giving face and bodies. We have seen the face option. Now I'll go for bodies option. So here we need to show the bodies as a boundary. So I'll select these two bodies as a boundary here. And now it will show only this option keep. Discard option will be by default gone here. Say it OK. It will again ask you for the extension type. You can see. Now the extension type here, it is showing a simple extension. But if I say coped with cuts, this extra portion will be extended here, covering this curve. You can see the difference. As I click, you can see here. In coped cut, it will cover up the full radius also. But in straight cut or simple cut, it will not cover or cope up with the radius here. So these are the corner treatments. If you want to add, you can go for this also. I'll say it OK. I'll keep the simple one only and then say it OK. So this was trimming using boundary. You can also use this command for extend. So for gap, we are going to edit the first rectangular tubing group 1. So in group 1, I'll select this corner and add one gap here. Say it 10 mm gap. Again say it OK. Now you can see gap has been added here. But if I want to extend it further, these gaps are added just to fill up the welded material here. But if you want to extend it further and you don't want a gap, so you can go for the trim and extend command. In oblique, extend command is also being shown. So I'll select the extend and trim command only here. And in bodies to be trim or extended, I'll select this body. And here these options should be ticked on here. It should be on, that is allow extension. Here also it should be put on, that is allow extension. And then we have to show the boundary. So again we can show boundary by faces or bodies. I'll show it by bodies only. I'll select this boundary as this body only. Now this part is extended here. So this command can be used for trimming as well as for extend both. Only thing is you need to keep this option on while extension, that is allow extension. If you don't put this option on, it will not extend, it will only trim the borders, it will only trim the sections. So if you want to extend, just put on this option allow extension and it will be extended instead of trimming. It will work both the ways. Say it OK. This was trim and extend command. You can see here now everything is properly trimmed. So after trimming, one more thing important here is that if you want to edit the cross section sizes, you can see here we have taken rectangular tubing as 60 by 40 by 3.2 and the other rectangular tubing as 50 by 30 by 2.6, and also the pipe size here given is 33.7. But if you want to edit these sizes or you don't want to take the standard sizes, your need is of different size, you can directly expand the structural member model tree. And in structural member model tree, you can see here the sketch of that particular tubing is given. So we can edit this sketch and apply as the required sizes we want. So if I want this size to be 65 mm and this size to be 45 and this radius or thickness to be different as 3.5 mm. So we can edit all the parameters here and then exit the sketch. So that tubings will automatically be updated there. You just need to go to sketch and edit the required sketch which you want to, You just need to go on the structural member, expand the model tree, edit the required sketch and put up the sizes as we want. Say it 40 mm if you want, and this as 33. That will automatically get updated if I exit this sketch here. So in this way you can edit the cross sections also and apply the required sizes you want. Next command we are going to see here is end cap. Select the end cap. So these end caps are provided on the cross sections such as rectangular tubings, circular tubings at the ends, as because if we keep these ends open only, then it might cause corrosion here due to oxidization and the internal surfaces may get rusted here. So to avoid that, we are going to provide end caps. You just need to select the face, flat face, and the end cap will be provided here. Now it is covering half of the thickness you can see here. It is because the ratio of offset is given as 0.5. If I say it's 0, it will cover the complete outer boundary of the face. And if I say it 1, it will cover the inner boundary of the face. And then you can also go for corner treatments, fillet or chamfer. I'll select chamfer either or fillet and then say it OK. Now the type of end cap I have taken here is, you can see outward. That's why this end cap has been projected outside the pipe here. If I want to change the thickness of the end cap, I'll select and say 8 mm here or 3 mm here. These end caps will be welded. So I'll put the thickness 5 mm. As the thickness is very low, it will be difficult for us to weld this cap here. Said OK. And now one end cap is added externally. If I want this end cap to be coplanar with this face, both the faces should be coplanar, then again I will select the end cap, say edit feature and go for the second option, that is inward. Sometimes we get that inward means it is going to go inside the tubings, but inward doesn't mean that it is going to be inside, but it will replace the length of the tubing here, and instead of going inside, this tubing length will be decreased here and this end cap face will be coplanar with the other tubing face. So you can see here, this end cap is not gone inside the tube, but the tube length is decreased here. That's why it is called inward. The third type given here is internal. Now in this we can say that pipe length will remain same, but the end cap will go inside the body. So to compensate the gaps between here, I'll say this offset ratio as 0. And the end cap will completely pack the internal portion of the rectangular tubing. But you can see this part is but you can see this end cap is flushing the rectangular tubing here. So to avoid this, I'll measure the radius first and then I'll add that radius. I'll delete this end cap. Measure the internal radius of the pipe. It is given 3.2. I'll again go for end cap, select the required face. Go for corner treatment as 3.2 and the type of end cap I'll select internal. I'll give the ratio 0 here, so there is no offset distance between cap and structure. Say it OK. You can see this end cap is completely covering the internal portion. Now if you want this end cap to be placed little bit offset inner sides, then you can edit the feature here. Go for the feature and in distance D1, inset distance you can see here. This inset distance only given for the third option. For first and second option there is no need of inset distance as the cap is going to come outside the tubings. So inset distance option is only given for internal type. So I will select this inset distance as 10 mm. So instead of coming at the face, it is coming internally as 10 mm offset distance from the face. Said OK. Now this end cap is fitted here. If I want to continue for all the 4 portions, I'll select this end cap option and just need to select the faces. The same conditions for the first one will be applied for the second also. Select other end caps or other openings also. You need to click on the face and then say it OK. So here the end caps are being provided internally with the offset distance of 10 mm. We are going to add the supports here as a rectangular plates. So for that we are going to select this face, say sketch, and then select the sketch, say center rectangle and add one bottom plate here. I'll say it 160 by 120, and then add the plate, say it features and extrude boss. So I'll say 20 mm here. Okay. Now this end plate has been added here as a support. I'll update this dimension. I'll make it smaller. I'll say 120 by 80 mm only. Again say update. And now if you want to pattern this, you can pattern these plates. For that we need to know the center to center distance. So we can find out by evaluating command. I'll say this tab evaluate and go for this measure option. Select the tubings and I'll go for center to center distance. There are three options given. I'll say center distance. This showing as 600. The another center distance horizontal. I'll select both the pipes. It is showing here as 1200. So I'll pattern these plates here. Go for features. Select linear pattern. And in directions, I'll show these edges here. For this one and this edge has two direction. Check the arrows of the direction and then go for the features or bodies to be patterned. I'll select bodies instead of feature. As we are working in Weldments, all the single parts are different bodies here. That's why I'm going to go for bodies option. Select the body, this rectangular plating here, and add the number of entities required. I'll say 2, and the distance here is 600, and the other one is 1200. Number of entities there also 2 only, and then say it OK. Now this base has been added to the structure here. Now while working on this part, you can see a cut list has been generated. This is very important that there must be a cut list showing each part and its sizes here. So this cut list is very important and it will be only generated if you have selected this option, that is Weldments, before starting the part. So you can see here I have selected this Weldment option. That's why it is showing the cut list here. And then we have started all the things here. Now one more thing remaining here is gussets. We provide gussets in between two adjacent faces so as to provide the strength and also provide the support for these faces so that they would not get diverged after applying the forces, as well as they will be stable as the gusset will provide strength between the adjacent parts. So to add gusset, I'll select this option. You just need to select the two faces, adjacent faces, and the gusset will automatically be updated. Only one gusset at one time you can add here. You can either go for triangular shape or you can go polygonal shape here. You just need to update the dimensions you require. I'll say 30 by 30 by D3 as 15, this distance as 15, or you can also change the angle here. If I want to change the angle, I'll go for the angle. I'll say it 60 degrees, or I'll say it 45 only now, and then say it OK. This gusset has been added here. So for the thickness orientation, there are options given here. You can see here about its own axis. You can make it at left side, right side, or at the middle, or else according to the face you can locate it at left side, right side, or middle. I'll select both the options here as middle only so as to orient this gusset at mid side. If I want it a little bit offset, and you can go for this offset option also, and then put up the value here. I'll say it's 6 mm. So now it is taking 6 mm from this edge to the inner face here, from this blue edge to this inner face. I'll off this option, and now one gusset has been provided. Similar way you can go for the similar way you can cover all the sides here by providing gussets, but you have to keep in mind only one gusset at a time can be provided here. But you have to keep in mind that only one gusset at a time can be provided here. So this was gusset command. Lastly, we are going to see this weld bed option. So in weld bed, you have to select the weld geometry or weld path option so as to provide the weld here. I'll select the weld path option here. In weld geometry, you need to select two faces and the common edge between these two faces will be welded. The number of weld width command will be increased here. So to avoid that, I am going to go for weld path here. So in weld path, you directly select the edges you want to weld and the weld will be provided there. So I have selected all the edges here, you can see. And after selecting all the edges, you need to provide the radius of the weld. I'll go say 2 mm. Then define the required symbol or type of welding. I'll say it fillet weld here. You can see number of type of welds have been shown here. First one is butt, the other one is square butt, and so on. So I've selected fillet weld, given the size as 2 mm, say it OK. You can see here. And suppose if I want to show that welding also, then you have to go in this view heads up tab. Here you have hide and show items. Go and say view weldments. As you say view weldments, the welding will be shown here. You can see here. If you don't provide weld bid here, it is not compulsory. You can directly show it in drafting also. The other commands such as extrude cut, hole wizard, chamfer, reference plane, and extrude boss are similar to the features command. There is no difference here. That's why I'm not showing that commands here. It is similar to feature ones we have seen already in lectures. Follow the playlist so as to understand the other commands also. If I want to add a glass here, I'll select this face, say sketch, and I'll select the corner rectangle. Select the corner from one end to the another. Features and say it extrude boss. And we can mirror this. I'll say it boss extrude and then say mirror. Select the reference plane in between. And this part will be mirrored there. I need to select this as a body here, not as a part. And now if you want to add the appearance, you'll go for the appearance. I'll select this tubing here. Say this piece as metallic one. So I'll say steel. Select the steel type and select the structural member. Weldment select tubes. So now this steel has been added here. But if I want to add this appearance as a glass for this 2 extrudes, then we'll select the appearance option again and then go for the appearance as a glass. I want textured glass. I'll select green color here. Drop it on this mirror. For the other face also. And while dragging and putting up, say it as a body only, the appearance. Then it will be applied only for that particular body, not for the complete structure. And now you can see glass appearance has been added there. And it is transparent also, you can see the ribs also here. So this was weldment structure. There are more things for this cut list. We will see in weldment cut list table in final lecture of drafting. That time we again will come for this option. And in detail we will provide the properties also here for this cut list. Now it is showing the number as 29. You can see. Now this cut list is representing the total number of single entities used for making this structure. Either it may be this boss extrudes or the bodies, we can see these glasses here, or it may be standard structures or gussets or end caps. The total individual bodies which are utilized to make this structure are 29. So the cut list is showing the total number of single individual bodies that are being used to make this complete weldment. Previously we have completed part molding, sketcher, assemblies and types, sheet metal, and now we have completed with weldments. Next lecture we are going to see plate weldments and then we are going to go for drafting them. And please follow and continue to watch the playlist so as to learn SolidWorks completely. Our channel is 4 Dimensions Infotech. You can contact us directly for joining the classes, and we also provide placements in core mechanical design. So thank you for today.